Hi, folks. A very good morning. And I came a little early just so that I can check the microphone. I can see if there is any issue with the live stream before we jump in. I'll also keep my eyes open on the live chat, so we could chat for a few minutes. And I'm planning to start at 10:05, which is 5 minutes past 10 a.m. sharp. So till then, let's wait for everyone to jump into the discussion, and I'll spend some time on the live chat here, and I'll try to answer as many questions as I can before we jump in. Okay. So if you have any issues, do let me know on the live chat with the audio quality or with the video stream. Things look fairly good to me as I see it. Yeah, I can see myself clearly. I can also hear myself fairly clearly. So no major issues for me there. Hey, good morning, folks. Thanks for joining in. Can everybody confirm if the stream is okay, if everything is good? Because I can hear myself, I can see myself clearly, even on my 4G connection. Hey, good morning, folks. Thanks for joining in a little early. So let's wait for everyone to join in. There are already a bunch of you who have already joined in. So let's wait for everyone, because I come a little early often to these discussions to ensure that there is no issues with the stream itself. Okay, good. No issues. Perfect. Good. Audio and video. So Amin asks a very good question. How to keep consistency in learning? Very, very important. Consistency is, I think, one of the hardest things, even for me today. Like, how do I consistently wake up every morning and do these videos or answer these questions or take mock interviews, design interview questions? How do I do it? So one strategy that has worked very well for me in my own professional experience and even in my personal experience is I try to set a schedule. So oftentimes I wake up before 4:30 a.m. between 4 and 4:30, depends on how cranky my son was the before night. But I try to wake up by 4:30, sometimes even at 4 if I have a good night's sleep. And I try to sit at my desk by 5 a.m. with a cup of tea, or a cup of coffee. I try to sit at my desk and I don't check my email, I don't check my WhatsApp, I don't check anything that is distracting. I sit down. By the time, for the first 3 to 4 hours of the day, I try to get the most important things done, because that way I'm starting my day with a very productive piece of work. I try to get my work done, all the critical, most important work. Some of you may have noticed this. I actually record a lot of videos early in the morning because my mind is fresh, I'm fully focused, and by the time it is 10 or 11, I try to get a good chunk of my work, if not all of my work. It's almost impossible to get all of my work done in 5-6 hours. But I at least start my day well, and that keeps the motivation levels high. So imagine from 5 a.m. to 11 a.m. I've written the notes, I've recorded a few videos, I've answered a few queries that students have, and I've prepared for the mock interviews I'm going to conduct through the day. Right? Then, see, I schedule my time, and that has helped me immensely. Because now I have a perfect schedule. I say at this time I'm taking a half an hour break, but it's very, very hard to stick to that schedule. You have to discipline yourself. You have to tell yourself that today. So another thing that has worked very well for me is I write a note on my laptop and I say from 5 a.m. or 4:30 a.m. to 6:30 a.m., 90 minutes, how much work have I gotten done? I try to review that work at the end of the day, thereby seeing how well did I work today, and I rate myself on day-to-day basis. This is what I used to do a little earlier. Now I don't do it because I've become fairly disciplined over the years. But even nowadays, whenever I think I'm not getting enough work done, just write down every day. I ask myself, have I done a good job today? So next day I say, okay, tomorrow I'm going to do a better job than yesterday. So it is basically a data-driven tracking of how well I'm doing on a consistent basis. I think that's one of the strategies that has worked well, not just at Applied AI course, but even when I was at Amazon or prior to that. Schedule. Try to, again, discipline is super important. Thankfully, I studied in a military school in Dehradun for 5 years. I've learned a lot of stuff from there on how to be disciplined. But it's about fixing a schedule and getting work done. That's very, very important. Okay. Sounds good. So how to manage office work and studies? Again, schedule. I'm sure you're not going to work from 5 a.m. to 8 a.m. on your office work. So spend those first 3 hours of the day studying, learning, right? Then you can prepare, get ready for your office, head to office. Anyway, in India, most people go to office at around 10 a.m. So wake up early, get your work done early, and cut down on your social media, cut down on your television. I mean, I don't agree with people who say I don't have enough time in my life. If the presidents and prime ministers of countries can accommodate time in their schedules, why not us, right? So I think we can surely make up or utilize or optimize our time, right? So somebody is asking about other live videos. So all the general lives that we have done are available on YouTube itself. Just go through our channel, you'll see all the past lives. If you're a registered student, all the lives that we do on weekly basis, you'll find them only on the desktop app, only for registered students. Okay, sounds good. So okay, sounds good. So it's almost 10 a.m. So let's wait for 5 more minutes, folks, because I see a lot of people jumping in. I'm just seeing the track here. We'll start the actual session itself at 10:05. Okay, that's what I mentioned a while ago also. In 6 minutes, we'll start with the actual session itself. In the meantime, I'll answer a few questions. Okay. So good, Vishal, a very good question that you asked. You find difficulty in connecting concepts. That's very, very interesting, because this is a problem. I'm very bad at remembering things. Like I'm very bad at remembering names, right? I'm very bad at remembering formulae. So one strategy that I do here is, imagine I'm learning 2 concepts. Let's take a simple example, right? Let's say linear regression and a deep learning model, right? I try to first draw everything, because I have a better visual memory than audio memory. Again, different people have different types of memory. I'm very good with visual stuff. I can remember diagrams. Most humans have a good visual memory, right? So I try to draw diagrams, and whenever I see an equation, I try to break it down and I say, what happens if I change this? That's a strategy that I've even employed while teaching the course itself, right? So I try to break down the concept and I say, what happens if this changes? And let's assume you take 2 concepts. For example, take a logistic regression and an SVM, right? So of course, you can say margin maximizer, all of that stuff. But if you look at it from a pure optimization standpoint, the way I connect these 2 concepts is, you have L2 regularizer in both places. Here you have logistic loss, here you have hinge loss. And I know the diagrams for hinge loss and logistic loss. That's all is the difference. That's how I connect different concepts. Even in the course videos, if you look at some of the sample videos, we do connect these concepts. Like I think every major machine learning technique that we discuss, we connect it to all the other techniques, because that's how I learn, right? If you teach me a new algorithm, I ask, what is this similar to that I already know of? And how can I derive this new algorithm from an old algorithm? By changing a few things here and there. Okay, so interconnections, because we humans are we are storytelling creatures, right? Imagine Ramayana, Mahabharata without the story element, without the interlinks, without the connections, right? Similarly, when you learn mathematics or when you learn any scientific area, right, the very important thing is to interconnect these concepts with one another. We try to do that as part of the course a lot. Again, this need not be like even trigonometry, right? When you learn trigonometry or calculus, try and interconnect these things so that it feels more like a story for you and less like a bunch of facts that are thrown at you. Okay. Again, I don't remember many formulae, but I can derive them. I mean, suppose if you ask me to work out the SVM formulation, I don't remember it at the top of my head. But give me 2-3 minutes, I can write down the formulation by using the basic geometry, by knowing what needs to be changed and what should not be changed. Right? That's how I learn, and that's what I try to also incorporate as part of most of the videos that I do. Right? Okay, sounds good. So somebody is saying he or Roshan does not have strong grasp on programming. So how to overcome this? What to prefer, math or code? Again, if you want to have a career in data science or machine learning, coding is mandatory, right? Of course, maths is also important, but I would rank coding as more important, because of course you have to know math also. Without math, you're going to make blunderous mistakes. But coding is much more at the lower level. It's like, should you know alphabets or should you know grammar? First, you should know alphabets, right? So that's very, very important. So coding is very important. And the way I learned coding, or the way I teach coding to people, or the way I've seen youngsters learn coding, is take up a problem, start solving it, start filling in those gaps, right? It's about taking a big problem, breaking it out into smaller portions, and learning each of these concepts. Again, if you want to learn some of the basics, just go to interviewprep.appliedcourse.com. That's one of the courses we have. We have a lot of basic videos and examples. So just go through those videos, you'll get a sense of how we, given a problem, how we break it down and start writing code in a very simple methodology, right? So that comes with practice. There is no shortcut there. Most people who learn programming they become good at programming by solving lots and lots of problems and by writing code, not by solving it in their heads, by actually writing code. That's how I learned coding myself. So this is very good. When you learn a concept, you forget it. Okay, the simplest way. See, I told you, right? I have one of the worst memories that I know of. My wife keeps complaining that I don't even remember the names of people that we meet. Right? I'm terrible at it. But the way I remember things, especially in machine learning or science or mathematics, I still remember calculus from my 12th class, right? Because I was teaching something recently for engineering students, and I said, okay, I still remember calculus, integration by parts, all of those things. The reason I remember is I try to visualize them. As I told you earlier, I have very good visual memory. I have very bad audio memory. That's why I don't remember names. But I can remember if you try to draw it in diagrams. For me, integration is not the integral symbol. For me, integration is area under the curve. That's how I remember integration. Differentiation for me is the angle of the tangent to a given curve. So I learn, at least this is my strategy. I'm not saying this is the only strategy. This is the strategy that I employ. Whenever I learn a concept, I try to learn it from a geometric viewpoint, and I also try to write diagrams. And of course, you have to revise. If this is the first time you're learning this concept, for example, if there is a research paper that I learned 10 years back, I've forgotten it because I've not revised it in my head. So constant revisions, maybe once every 3 days initially, then once every week, once every 14 days. That's one strategy that can help you not forget these concepts. Okay. Yeah, we are already at 10:05. So let me change the screen. Let's go into the discussion itself. Okay. So just give me a second now. I'm super excited. I'll also give you a motivation on why this whole thing started. Just give me a second. So let's get into the discussion itself. I hope everybody can see this. Okay, let me just see. I hope everyone can see this. Just give me a second. Okay, I'm just making sure that everyone can see the slides or the diagrams that I've drawn. These are not exactly slides. These are simply handwritten notes. I hope everybody can see them. That's important. Okay, can everybody just confirm if you can see the slides that I've put up here, or the handwritten notes that I have here? Can everybody confirm that? Okay, so yeah, so I've just written some handwritten notes. Can people confirm that? Okay, yeah, you all can see, right? So just wanted to cross check that. Okay, so again, how is this motivated from? Okay, so let me give you the reason why I wanted to do this for a long time. So I was invited to a school recently to give a talk on AI. Okay, this is a very popular school in Hyderabad called the Oak Ridge International School. And they asked me, they keep having these guest lectures from industry experts. They asked me to give a small lecture on any topic of my interest to 9th class students. Okay, that was a big challenge because what do I know that a 9th class student knows? Then I asked them, okay, is this CBSE? I said, yeah. They said yes. I said, can I have the syllabus for CBSE mathematics? Okay, I said, then I took up a challenge. I asked myself, can I teach a 9th class student how YouTube recommendation engine works? That was my challenge. Okay, I said, all that they know is basic mathematics. I've never taught a school-going kid in my life till date. Okay, except probably when I was a school-going kid myself. So this was a nice challenge. I've taught people who are engineers, who are working professionals, who are engineering students, etc. But I've never taught somebody who is below 10th class, right, or 10th grade. So I said, okay, how do I now explain them? Everybody, most of the people who are in the 8th, 9th grades today have used YouTube at some point or other. So I have asked myself this very simple question. They have used YouTube. They've seen YouTube recommendations. I asked them, do you know YouTube recommendations? Everybody says yes. Then I told them, shall we build a YouTube recommendation system in the next 1 hour? They said, are you joking? I said, no, I'm not joking. I'm very serious. Okay. So again, this is an experience that I learned and I thought I'll do this for everyone's benefit. Because I want to show you that you can build a simple system. I'm not saying we are going to build a state-of-the-art system. The state-of-the-art systems for recommendation systems is fairly advanced. They mostly use deep learning today, and some amounts of reinforcement learning is being experimented upon, etc. I'm not even going to go into that depth. My objective here is, can I build a simple first cut YouTube recommendation using basic mathematics at high school level? The goal here is with high school level mathematics. High school is from your 7th, 8th grade onwards, right? If I'm not wrong. So that's the goal here. Can we do that? And I felt we can do it. So let's get going. Okay. Of course, most of the viewers here are not 9th grade students. You're working professionals. So I will not teach it at the level of teaching a high school student. I'll go slightly above. I'll also discuss about some real world challenges on how to deploy these recommendation systems. I'm assuming some of you have some background in software engineering or some background with code and stuff like that. Some of you have done engineering or studied sciences or statistics or mathematics, etc. Right? So this is the motivation. So let's get into the agenda itself. So the agenda for today's discussion is as follows. It's fairly simple. So first, let's understand the problem. Very, very important in any data science task is to understand the problem that we're trying to solve. Then we'll simply use 9th and 10th class mathematics. I'll tell you this topic also. We'll use simply sets. We all know about set union, set intersection, these concepts, right? This is something that you may have learned today in CBSE syllabus. It's in 9th grade, right? I think in some state syllabus boards, it's also there in 8th grade and 10th grade also. So using simple concepts, I mean, you don't even have to know concept of sets. Using common sense and basic mathematics, we'll build a first cut solution. This is by no means a state-of-the-art solution. First, we will learn this. Okay. Then we'll use, again, once we learn the first cut solution, we'll also learn how to productionize this model. Or if you're a data scientist, how do you deploy this model? How do you now put it into production? How do you now make it available so that it can run in production? We'll also briefly discuss about it. Then all of you may have studied mathematics in your 11th and 12th class, and you have learned about eigenvalues and eigenvectors. I've recently learned that some students in some state boards also learn eigenvalues and eigenvectors in 10th grade itself. So we'll use, again, not set theory, slightly advanced mathematics like eigenvalues and eigenvectors, and I'll connect this concept to something called as matrix factorization. Again, we'll not be able to go too deep into it because we wanted to do a 1 hour session here, giving you a high level overview. Please understand that this is not a cutting edge solution. To learn the cutting edge solution of building state-of-the-art recommender systems will take us like 20 to 30 hours to learn the basics. Right? Again, in our course, we cover this from the very basics, like from basic set theory, we cover basics of what is an eigenvalue, because many people I see have forgotten what is an eigenvalue, what's an eigenvector, right? What is matrix factorization, what is deep learning. We'll cover, see that requires me at least 20 to 30 hours to cover, right? So in a 1 hour session, I thought I'll give you a glimpse of how simple. Again, many people have this fear that this is super complex topic. This is impossible to build. Again, this is something that I learned from 9th class students also. They said, are you joking? Literally, that's what they told me. I said, no, I'm very serious. Let's build it, right? And so let's do it. Let's do it. Okay. So let's go now. Okay. So let's understand the problem first. Okay. I'll keep pausing. So the model that I'll employ here is I'll pause at a few places and I'll ask your suggestions and your thoughts on a problem. I would love to hear it in the chat section. Okay, I'll change this from this screen to the YouTube chat window, right? So I'll change from this screen to, this screen, right? To hear your thoughts. Okay. So somebody is asking about the slides. I'll share a link of all these. I'll send you this PDF. I'll put it in the video section here itself after a while. After this session is over, I'll share these slides. Don't worry about it. Okay. So let's understand the problem definition first. Okay. So this is a video of applied AI course, a video that we did a few months back, and this is the current video. So if you go to YouTube, right, so this is called the current video that I'm watching. So given that I'm watching this video right now, I get a bunch of recommendations here. These are all called as recommended videos. This is what is called as video recommendations problem. While watching this video, YouTube, why does YouTube do this? YouTube does not want users to spend too much time discovering content that they may like. So YouTube does this recommendation for you. YouTube says, okay, these are all the videos that you may be interested in, and I can even set it in autoplay, which means as soon as this video is over, this video will start playing. As soon as that is over, this will start playing. As soon as that is over, this will start playing. So on and so forth. So this is helping users who is a customer of YouTube who is watching this video find new video content that he or she may be interested in. So it is improving the user engagement. User engagement is one of the most important metrics at YouTube, right? They want users to spend more time, okay? Because then users will upload more content, users will spend more time on YouTube, and again, that also generates more revenue. See, at the end of the day, YouTube is also a business owned by Google, right? So if people spend more time on YouTube, YouTube can show more ads and thereby generate more revenue. They have to generate revenue to survive, right? So the whole objective here is, can you recommend videos? If you think about it from a pure problem, you're watching this video, given this video, can you recommend videos which are likely to be watched by this customer who is watching this video? Okay, that's it. These are highly likely. These are videos which are highly likely to be watched after this. That's it. And today, again, I do this a lot of times. Again, you see video recommendations like this. You also see recommendations like this on Netflix. Those of you who have used Netflix or Hotstar, right? Very popular services in not Netflix, but Hotstar is very popular in India, right? Netflix is just getting started. So if you see any of these services, they also recommend other videos that you may like. Similarly, if you have ever heard songs, whether it's iTunes, right? Whether it's iTunes or whether it is Savan or Ghana, any of these services, any of these online streaming or Spotify, right? Any of these streaming services, based on the song that you're listening and based on the songs that you listened to in the past, they will recommend new songs. Similarly, Amazon does a terrific job here. Amazon, Flipkart, Myntra, all of these companies recommend new products, because this improves the user engagement by helping users discover good content. That's what users want, literally, right? And that's what companies also want, because that helps them generate more revenue. This is our business problem. We have to always study the business problem and the real world problem that we are solving before we jump into mathematics. Very often people just directly jump into mathematics without understanding what is it that we are solving. We want to find videos which are highly likely to be watched by a user who is watching this video, given that I have other videos also he has watched in the past. I have the data. Very simple question, right? Very simple concept. Okay. So now given this context, okay, what data does YouTube have? Okay, I left this slide blank intentionally. Okay, what data does YouTube have? What data do you think YouTube collects? Okay, I want to hear from you guys. What data do you think YouTube collects, which we can use to build this recommendation system? Okay, so I would love to hear your thoughts on this. Okay, so let me change to the chat window here. So if you guys can explain what you think, again, please type it. What do you think is the type of data that YouTube collects when you're watching videos? What type of data does a data scientist at YouTube have? Tags, okay, very good. User views. So I'm assuming when you say tags, okay, so you're saying every video you can tag it with some keywords. Okay, that's what I'm assuming. Cool. Okay, this is moving. User views, which means which video has been watched by which user. Okay, playlists, very good. Our history, I think by user history, all of you mean all the videos that I've watched. A search history, very good. Again, many people don't know, but YouTube is the second largest search engine in the world after Google itself. So user history, user text, cool. Subscriber information, very good, very interesting. Previous history of users watch, tags, user likes, yes, likes and dislikes. This is also very interesting. Personal preference. Again, see, look at all the data that YouTube collects. YouTube knows which video you're watching, whether you liked it or you disliked it. It has that information also. It has information on whether you're subscribed to a channel or not. Right? All these, again, demographic data, very interesting. What is the rough age group of the user? Right? Somebody who is in their 30s may be interested in baby videos because they're most likely going to have a baby or they have a baby, right? So things like that, right? Or somebody who is in the 20s who want to travel, you might want to show them travel videos. Very good. Search is a brilliant idea. So all of this data, very good. I mean, terrific. Great participation, guys. Loving it. Okay. This always is motivating when you see people participating. So there is lots of data, very, very good points that you guys brought up. What we can do is, again, all this data, the actual YouTube, right? The true data scientist at YouTube uses all of this data. The true data scientist at YouTube uses all of this data that you all have mentioned. In addition to it, they could use data from Android, because Google owns both YouTube and Android. They can use data from your Chrome browser, right? They can use data from your Google search, right? So because Google owns all these entities, right? If you have a Chromebook, what you're doing on Chromebook, right? So Google, in addition to using data from YouTube, also uses data from other services that they provide. And that's why there is a lot of legal, entities like European Union are now placing more restrictions and fines on Google because they just use this data left and right. For our discussion, what we'll do is this. For our discussion, we'll use some simple data. What is the most useful data here? The user viewing history. The user viewing history. Let's just use one piece of data. Of course, if you were to actually work at YouTube and solve this problem, you're going to use all the data that you guys have mentioned and other data from non-YouTube services which are owned by Google. But because there's a simple first cut solution, right? Let's just use user viewing history, which means given a user UI, right? What are all the videos that he or she has watched? Let's assume, so I'll use U for users, V for videos. Let's assume I have user I who has watched video 1, who has watched video 3, who has watched video 6, who has watched video 18, who has watched video 126. These are the IDs of the videos. Every video on YouTube has a unique ID, right? So let's assume these are all the videos. Again, in watching videos, there is a temporal element also. Temporal basically means time based. Probably I watched V1 first, then I watched V3, then I watched V6, then I watched V18, then probably I went and watched V3 again. But we'll just ignore it for simplicity, because building a temporal model or time series model is far more complex, right? So we'll not go into the temporal models. Let's just simply say I take the data from the last 7 days. I take the last 7 days data for this user. Let's just simply last 7 days data. Okay, very simple, or last 30 days data, whatever. Let's fix the number of days, because a user's today probably I'm watching videos on let's say a computer organization, or how operating systems works, right? That's what I was actually doing a few days back. Maybe 1 month back I was looking how to teach calculus better. Okay, 2 months back I was learning how to teach probability better. Okay, so within every few days the types of videos that we watch also change, and we want to recommend more relevant. Again, YouTube, what it does is it shows videos, it shows new recommendations based on the more recent ones more often. Okay, while it might show one odd recommendation based on your subscription, based on whether you're subscribed to a channel or not, even though you watched that channel long ago, it mostly looks at your recent history. That's called a recency based model. That's what is called a recency based model, or recency based recommendation system. Very simple. The word recency means what you have done recently, right? So in the last 7 to 30 days, let's assume these are all the videos that I watched. So let's just use the data from the last 7 days, just for simplicity. Again, whether it should be 7 days, 30 days, 60 days, 45 days, depends on how do you decide that? You decide that by doing lot of data analysis on YouTube data itself. So for our case, let's just simply assume that last 7 days data is good enough. We're making some simplifying assumptions here. Okay. So we'll just have this data. Now comes the most interesting part. All of you have heard of this term called matrix, right? Probably in your 10th class or 11th class or 12th class, 10th or 11th or 12th grade, right? We all have learned about matrices. We learned about diagonal matrix. We learned about different types of matrices. We learned about determinant of a matrix, adjoint of a matrix, inverse of a matrix, all of that stuff. How often have you used matrices? That's the problem. Actually, the biggest problem in most education is We teach them beautiful concepts in mathematics, but we don't connect them to real world. That's unfortunate part of most of, again, there are some brilliant teachers out there, I've seen who do that. But the moment you connect any mathematical concept to real world, people will not forget it. Okay, so look at this. So imagine, what does a matrix do? Matrix has rows and columns. So this whole data that we were talking about, right, this whole data of users watching videos, can I store it in a matrix? A simple matrix. See, what is a matrix? Forget about all the complex operations that we have on a matrix. Can I store it in a table-like form? What is a matrix? Matrix is nothing but simply a table. If you want to think about it in layman's term, in a non-mathematical viewpoint, it's just a simple table. Here it is called as a data matrix because we are storing all the data that we want to use in this matrix. That's the goal here. Okay. See, I'll tell you how this is filled. Imagine user 2 in the last 7 days has watched video 3. Then we'll place 1 here. Okay. Let's assume user 2 has watched video 4 also. We'll place 1 here. Let's assume user 2 has not watched video 0. It will be by default 0. Simply default, by default value is 0. Now in my system, I could have n users. Look at this. I could have n users, u1, u2, u3 up to un. So each user corresponds to a row like this. And I could have m movies. Look at this, vm. M is the number of movies. I write number with a hash. Okay, it's a short form notation. N is the number of users. So if you think of this whole matrix, this is what is called as a binary matrix. This is what is called as a binary matrix. Again, don't worry if you don't know what is an inverse of a matrix, adjoint of a matrix. I promise you, I'll not use that. Trust me, I'll make it extremely simple. Okay. So it is called a binary matrix because you only have ones and zeros. Has this person watched it or not? Of course, this person may have watched, user 2 may have watched video 3 multiple times, but we are just ignoring that for now because we want to build a simple solution. So what is this matrix now? If you think about it, what is this matrix? Let's call this matrix as A. How many rows does it have? It has n rows. How many columns does it have? It has m columns. So this is what is called a matrix of n rows and m columns. If you recall, you might have written this in your 10th class or 11th class or 12th class, right? So I have n users and m videos. Remember, typically, does anybody know how many users are there on YouTube? YouTube, as of the most recent statistics, has 1.3 billion. Billion is 10 power 9. This is roughly the population of India. Roughly the population of India. Okay, those are the number of users who are on YouTube. The number of movies or the number of videos is in few hundreds of millions of videos. Okay, again, this number I could not find the exact number, but I'm sure it's a few hundreds of millions of movies. So this matrix is massive sized matrix. It's a massive matrix. Okay, it's a massive matrix. Very often when you are a school going student or even in your undergraduate days, you might have encountered matrices that are 2 by 3 or 4 by 5. The moment you see anything more than 4 by 4 matrix, you'd say, wow, this is too big. But in the real world, you encounter matrices that are billion rows, few hundred million columns. Okay, and this is a real data. Let's assume all of the data that I have, that I want to use, is represented like this. Very simple representation, right? 1 basically means this user has watched this video in the last 7 days, at least once. Okay, 0 means he or she hasn't watched this video. Simple. This is my data, right? Again, I'm building a very simple solution. I'm not building anything that is close to state of the art. Okay. Now comes the most interesting thing. Now, given this data, okay, so let me go take a step back here. Okay, let me take a step back here. Okay, so given this data, now how do we solve the problem? Okay, how do we solve the problem? Okay, very simple question. So what is the problem that we are solving? Let's understand it mathematically first. Let's understand the problem that we are solving mathematically first. The problem we are solving here is you have a user UI who has watched videos V1, V6, V8, whatever, some V15, and probably he's watching V18 right now. He's watching this video. Now you want to recommend a set of videos. You want to recommend a bunch of videos, some ordered set. Or you want to rank videos and say, this user may like video 69. This user may like video 76. This user may like video 189, etc., etc. And you also want to rank them. You want to say he has a higher likelihood of liking video 69 more than video 76. You also want to rank these videos. That's very important. Okay, the user has watched all these videos. He's probably currently watching V18, or probably these are all the videos that he has watched in the last 7 days. Now you want to rank list. You want to provide a rank list, or you want to provide a ranked list of videos that he or she may like. That's the challenge here. Okay. Now, how do we solve that problem? Let me give you one simple idea here. One simple idea here is, okay, it's called the idea of similarity. Very simple concept here, almost commonsensical. The idea of similarity is as follows. So we know all these videos that he or she has watched, the user UI has watched. Can I find videos? Can I say video 18 is very similar to video 69? It's very similar. Okay, can I say video 15 is also very similar to video 69? Can I say video 8 is similar to video 76, and so on and so forth? So for each of these videos, can I get a set of similar videos? For this video, can I get a set of similar videos? Imagine for each of these videos, if I can get a set of similar videos, right? So V1, let's assume I have set 1 of similar videos. For V6, I have, let's say, S2, so on and so forth. Using these sets, right, I can just combine all these sets and I can generate a new set like this. Imagine, look at this simple thing, right? Because V18 and V15, both of them are similar to V69. V69 is similar to more number of movies here, or more number of videos here, right? Hence, it's better to rank it above V76. Let's assume V76 is only similar to V8. Let's assume V76 is similar only to V8. V69 is similar to V8, V15, and let's say V1 also. Let's assume 69 is similar to this. So in favor of 69, you get 3 votes. 1 vote from V18, 1 vote from V15, 1 vote from V1. In favor of V76, you get only V8 as the vote. Right? So since there are more votes, since this video is similar to more videos that I've watched in the past, makes sense to rank this above V76. Very simple concept here. Now the problem has changed. The problem has gone from recommending videos to finding similar videos. So the objective here is this. Given any video Vi and Vj, given 2 videos like this, can I find the similarity between these videos? Can you somehow mathematically compute the similarity between these 2 videos? If you can mathematically compute the similarity between these 2 videos, imagine I have a function like this, a mathematical function, which given any 2 videos tells me what is the similarity between them. I'm done. Then I can take video V1. I'll simply take video V1 and I just compute this similarity for all the other videos. Whichever videos have the highest similarity to V1, I'll just say these are the most similar videos. Very simple concept here. So the challenge, the mathematical challenge here is, how do you define similarity between 2 videos? Of course, here a very interesting problem, right? Again, remember, I want you to come up with ideas using the data matrix that we have. Okay, using the data matrix, because we are limiting ourselves to just using the data matrix, right? What is a data matrix? Okay, so let me go a step back. This is my data matrix, right? So using my data matrix A, how can you simply compute the similarity? Very simple concept here. Okay, so let's go to this problem. Okay, so just a second. Okay, so the question here is this: how do you compute similarity between 2 videos using the data matrix? Okay, now I would love to hear your thoughts on the chat window. Okay, so let me just jump to the chat window itself. Okay, yeah. So any ideas, folks? Using matrix product, okay? Using matrix product, okay? Frequency of V1 and V2 for users. Okay, how often? Okay, by frequency you mean how often have others have frequency, which means frequency just measures popularity, right? You just don't want to show popular videos. You want to show very personalized recommended videos, right? So People are saying dot product, cosine similarity, all of that. Okay, some of you know this. Okay, cool. Eigenvalues, eigenvectors, how? Tell me basic stuff. Correlation between the videos. How do you measure intersection? Let's use simple mathematics, guys. I'll go into cosine similarity, eigenvalues, eigenvectors. Let's assume you're a software engineer solving this problem. The question, somebody wants me to repeat the question. This question here is, how do you compute the similarity between two videos using the data matrix A? That's the question. Okay. Channel and genre of the videos, but that's not the data that we have, right? We have limited ourselves. I agree with you. If you're actually a data scientist at YouTube, you would probably use the genre of the video, the characters in the video, the language of the video, and all of that stuff. But here we want to compute the similarity by just using, very simply, by just using the data matrix. How do we do it simply? Okay, how often people see VI also see VJ? Very good. Okay, so very good. How many people who watch VI? Let's just cut through all the mathematics. Again, mathematics is just a tool, folks. Okay, mathematics is just a tool to serve our needs. Okay, so to compute this similarity, just give me a second. Okay, so how do we compute this similarity? Okay, so remember, mathematics is just a tool. It is the intuition which is often very important. I would say intuition is more important because you can learn mathematics and you might forget mathematics, but intuition is more important. Okay, so look at this. So this is my data matrix A. This is my data matrix A. As somebody rightly pointed out, it is intuition that is important. Cosine, tomorrow there might be a new metric. Today you may have sets. Tomorrow you may have cosine similarity. Metrics might change, but intuition is important. Okay, intuition stays with you for a lifetime, and intuition is how you remember things for the long term. Okay, look at this. Imagine I have this video and this video, two videos. Imagine I have three videos: VI, VJ, VK. Let's assume I have these three videos. VI and VJ are watched. Look at all the users who have watched VI. U1, U2, U3, UN. Rest everybody, let's say, is 0. Let's all the other users, let's say, is 0. All these are 0. Let's just say for simplicity. All these are 0. So let's just say all these are 0. Let's just say all these are 0. Just for simplicity, let's say all these are 0. Okay, now, so how many users have watched both video 1 and video 2? 1, 2, 3. So there are 3 users who have watched both VI and VJ. How many users have watched VI and VK? Let's look at that. VI and VK. Imagine I want to find all the videos that are similar to VI. So 1 and 0, which means UI watched this but did not watch this. So watched this, did not watch this. Watched this, did not watch this. Watched this, did not watch this. Only one. There is only one user who has watched video I and video K. While there are 3 users who have watched both video I and video J. Right? There are 3 users who have watched it, which means for VI, VJ seems to be more similar, logically speaking, because look at this, users who have watched VI, more number of them have watched VJ and fewer of them have watched VK. Common sense. Okay, so VI is similar to VJ than VK. So if I have to sort them, if I have to order them, I will always order VJ above VK in terms of similarity because there are more of these, right? So if you think of this as a set, all the ones which are 1. So if you think of this as a set, if you think of VI as a set consisting of U1, U2, U3 and UN. So VI consists of user 1 because user 1 has watched them, user 2, user 3 and user n. Similarly, VJ, if you think of it as a set, right, consisting of U1, U3, right, U4 and UN. Similarly, you can think of VK as set consisting of U4 and UN. Then I can simply take the intersection of these two sets. Look at this. What is this? This is the notation for intersection of two sets. Intersection of two sets followed by cardinality of the set. What is cardinality of this? This is how we write the cardinality of the set. Cardinality of the set means the number of elements in the set. Right? So VI intersection VJ. VI intersection VJ is the set U1, U3, U4, right? Sorry, U1, U3, UN, sorry, not U4. That is the intersection. Now, what is the size of this? This size equals to 3. right? The size of this set. This means cardinality of the set or the size of the set. Cardinality is a fancy mathematical word. What it means is the number of elements in the set. That's all. Okay. So can I use simply similarity between these two sets? Can I use simply similarity between two videos as the intersection of these sets that I've computed? This is one way of doing it. There is one more simple way. There is one more simple way of doing it. Let me also show you another way. So that is the set theoretic view of doing it. So this is the set theoretic view. This is the set theory view. There is also another view which programmers and software engineers love. Okay, take this as a vector. So if you're a software engineer, right, you know arrays and vectors, right? An array. Forget about vectors. You know arrays, right? So think of this as array Vi. Think of this as array Vi. Think of this as an array Vj. So this is your array Vi. This is your array Vj. What is the size of this array? N elements. What is the size of this array also? N elements. So now if you multiply the first element with the first element, look at this, first element with the first element, you get 1, right? Then multiply second element with the second element, you get 0. So wherever this user is watched 1 but not the other, or if both the users have not watched it, you get 0. Only when if both the users watch, you get 1, right? So again, you get 1 here, you get 1 here, you get 0 here, right? You get 1 here. So what is this? This is this whole sum. So if you think of this as array, and if you do component wise multiplication, this is what is called as component wise multiplication, right? Or you multiply the first element with the first element, second element with second element, third element with third element, and sum them up. This will simply give you the set intersection. So if you were to actually implement this in code, you can just think of this again. If you know C programming language, how do you represent a matrix? You represent it using a two-dimensional array, right? Even in Java or other programming languages, Python, you can represent it as a two-dimensional array, right? Very simple. So if you're a software engineer, it's easy to understand it from the perspective of arrays. If you're more interested in the mathematical view of it, you can think of it as set intersection. Okay, cool. Now let me ask you the tricky question. Okay, so let me ask you the tricky question here. So let me go into this. Let me see what is the next slide. I don't remember what the next slide is. Just give me a second. Okay, so before we go into the issue, okay, now given this simple understanding, let's see how we can build a simple solution. Okay, let's understand this. Then I'll ask you a very interesting question. Okay, suppose I'm user I. At time t1, I have watched video v1. At time t2, I have watched video 26. I am at current time t. Now I want to recommend movies, right? So, or I want to recommend videos. How do I do it? Look at this. For the similarity between Vi and Vj, if I place this in a matrix in cell Sij, imagine if I have Vi and Vj, right? This is similarity between Vi, Vj, right? If I place this in a matrix, I get a matrix S. This matrix S has m rows and m columns, where m is the number of movies. This is an m cross m matrix. And what am I storing here? In the ith row jth column here. In the ith row jth column. For example, look at this. What do I store here? I store, in this cell, I store the similarity of video 26. Look at this, video 26 and video 3. That's what I'm storing here. Because I can compute this, right? Given my data matrix. Look at this, given my data matrix, I can compute this for all pairs of videos. Of course, that will take a lot of time, because you have hundreds of millions of videos and billions of users. It will take a lot of time. But once of course, there are a lot of optimizations in algorithms on how to do it fast and all of that. There are tons of optimizations in algorithms, right? Let's assume we do that. Okay. So now what you have here. So now what you have here is a system like this. So I have this matrix S. Okay, we call this S because it's a similarity matrix. This matrix stores the similarity between every pair of movies, right? Now here, look at this. This is actually a symmetric matrix. Okay, because look at this. The similarity between video 2 and video 3 is same as the similarity between video 3 and video 2 because the set intersection here is the same. So S of Vij, so Sij is equal to Sji. We all may have learnt about this, right? These types of matrices when we were in school. This is where they're actually used. Okay, now let's go back to the original problem that we were solving. Okay, connecting the dots. Again, connecting the dots to what you learned in school is very, very important. So again, for most of machine learning, if you just know up to your calculus, not even integration, if you know up to differentiation, you can you can learn most of machine learning very easily. Okay, so let's assume I'm at currently time t. Now I want to recommend movies. So what do? I find all the videos that are similar to 26, which means I go to this row now. I literally go to this row and I say which of these videos are most similar to 26. Right? Let's assume I pick 5 videos. Let's assume I pick top 5 videos which are similar to video 26. Just a while ago, I also watched video 1. So I go to row 1 here and I pick 5 videos. I also pick 5 videos here which are very similar to S1, the most similar videos. Now I have 10 videos here. Some videos may repeat. There might be some video which is similar to both S1 and S26, or which is similar to video 1 and video 26. So it will be there in both these sets. So now I have a set of 5 videos here. I have a set of 5 videos. Now given this set of 10 videos, if a video repeats in both of them, just rank it higher. Just simply rank it higher. That's it. So for remember, you're getting a mathematical score. You're getting literally a number. So in the previous thing, very importantly, what you have to recognize here is you're getting a number to represent it. Okay. Because you have numbers, you can compare them because you have numbers. That's very, very important. Because we have numbers here, the similarity scores are numbers, which means I can compare. Right? Suppose, let's assume V26 is similar to V3 and the similarity score is, let's say, 126. V1 is also similar to V3. V1 is similar to V3, but the similarity score is 162. I can just sum up all of this. So for every video, I get a score like this, a similarity score. So I can just sum up all the similarity scores and rank them. So very simple. Imagine instead of 2 videos, I watched 10 videos in the last 1 day or last 7 days. Right? I'll just use all those 10 videos, pick up the videos which are very similar to this, sum up their similarity scores and pick the ones that have the highest similarity. In this case, maybe V3 has higher similarity, maybe V6 has slightly lower similarity, so on and so forth. This is how you can actually solve the whole problem. Of course, there are actual challenges in this. I'll also explain about how to productionize this model in a small scale, not at YouTube scale. At YouTube scale, you would require really, really cutting edge distributed systems. I'll also talk briefly about it. Right? So I hope you understood the whole flow of things now. That's very, very important to get. Okay, so now the next very important thing here is, okay, so we've learned some basics, right? Now let me go to the screen here. Okay, so there is one problem here. Okay, there is one problem here. I want you to guys tell me what is the problem with the similarity measure that we have. What is the similarity measure that we just designed? Similarity between 2 videos, Vi, Vj is equal to set Vi intersection set Vj, the cardinality of the set. This is the metric that we are using. This is called the similarity metric, or metric basically helps us to measure things. What is the problem with this? Again, this is the most important thing. I want you to guys come. Till now, some of what I've told you, there is a problem with this. This doesn't work in all cases. What is the problem? Good question. So this type of metric has flaws. So let me call it that way. Instead of calling it a problem, it has a few flaws. Can anybody find out what is a flaw in this measure? This is a simple measure, right? There is a problem, there is a flaw in this measure. In using this measure, we could make mistakes. Can anybody figure out what that mistake is? That's the question. Again, this is the very, very interesting, this is the ingenious part. Till now, what you have learned is very simple. This is the slight leap, small innovation, not rocket science. Okay, I'm not going to cold start all of that. Let's assume there is no cold start. What is a cold start? Cold start is, imagine if I get a new video. Cold start problem is basically when I have a new video for which I don't have any data. Of course, that's a problem. Okay, so I'll also take that. Fine, new videos. Okay, fine, I'll take that. Okay, so if there is a new video, we have a problem. But if you have a new video with no data, whatever similarity measure we come up with will have a problem. Right? Because you don't have any data. Imagine Vj here is a new video. If it's a new video, there is no data to start with. So whatever you define this as, you will have a problem because you don't have data. Right? So flaw means mistake. Yeah, so that's what I mean. Okay, so people are talking about some upload mistakes, etc. Let's ignore that for now. Okay, of course, In a real, if you're a data scientist anywhere, there will be hundreds of real world problems. But let's simplify it now. Okay, after finding similarity, we may find similarity of more videos. So what? When intersection is null. Okay, when intersection is null, what does imagine if the intersection is null. What does that mean? It could mean two things. VJ is a new video which has just been uploaded. That's where the intersection is null. That's one possibility. Okay, in such a possibility is called as a cold start problem, because we don't have any data for VJ. That's why it's called the cold start problem. The other problem is VI VJ have enough data, but they're not intersecting. That means VI and VJ are dissimilar, right? VI VJ are dissimilar. So what's the problem there? So because they're dissimilar, their intersection is 0. If their intersection is 0, that means they're highly dissimilar. No problem with it. So cold start. So just because the intersection is 0 does not mean everything is a problem. There may be lots of intersection. The other way of thinking. Good. This is a good point. What happens if there is a lot of intersection? When does lot of intersection happen? So VI and VJ, if there is a lot of intersection, what does that mean? What does that mean? Good point. Somebody said memory issue. I understand there are problems with deploying this in production. But of course, to deploy it, we use really high-end distributed systems. Don't worry about that. Biased by user pattern. We want it to be biased by user pattern, right? We want the system to learn from user patterns, right? So keyword is not very similar. Again, we are not using keywords anywhere in the data, right? Okay, so let me show you an example. Okay, probably you'll be able to appreciate it better then. Okay, sorry. So let me show you a simple example. It's always good to understand with examples. Let's take this, right? Okay. So the problem is actually with something called as popular videos. Imagine you have some viral video, some music video, or some movie launch video. They're extremely popular. So imagine I have video VI, VJ, VK. VK, let's assume, is a popular video, which means lot of people have watched it. Let's assume just this is my data matrix, just for simplicity. I just wanted to show you this problem. Okay, look at this. VK is watched by everybody. Every Tom, Dick and Harry watches video K, because this is probably a popular music video, let's say, or a viral video of some sort, like the cat videos, the baby videos, etc. Now, what happens in this case is, now let's compute the similarity between VI and VJ. Look at this. One user, if you look at this, VI, VJ are very similar because they exactly watched the same videos. Look at this, they're exactly watched by the same users, I'm sorry. User 1, user 2, let's say user 10, user 11, let's just say. So VI and VJ are very similar because exactly, see, this user watched both of them. 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 Other users did not watch any of them. So if you think about it logically, VI, VJ similarity should be significantly higher. When I place an arrow mark here, that means it should be very high as compared to similarity between VI and VK. But if you look at the similarity between VI, VK, 1, 2, 3, 4. If I use the metric, if I use this metric of intersection, what is the similarity between VI, VK? 4. What is the similarity between, VI, VJ? 4. VI, VK is also 4. Look at this. What is the metric that we are using? Just simple cardinality of intersection, right? If I simply use my metric is similarity between videos IJ is VI intersection VJ, the cardinality of this set. If I use this logical, let's think about it from a real world perspective. If this is the case, VI, VJ, if this is my data, very small data I'm taking just for example. Okay, my similarity here is 4, my similarity here is 4. The larger the number, the more similar they are. The problem here is VI and VJ are very similar, but VI and VK need not be very similar. This is just a popular video that is watched by everyone. That's it. It so happens that these users have also watched it. But there are also a lot of instances where this user has watched it, this user hasn't watched it, but this user, there are lots of instances where there is a user here who has not watched this VI, but watched VK. This is like Gangnam style video, let's say. It has billions of views, guys. Like people who don't even understand Korean like me have watched it at least once, who don't know what Gangnam is. It's actually, I learned it later. It's actually a location, it's actually a posh location in Seoul, it seems. Okay. So the important thing here is if you have a popular video, This will look similar, this will be similar, this will end up being similar if I use this metric. If I use this measure or this metric, it will feel similar to every other video, even though it's not. It's just a popular video. So how do we fix it? There is a very nice fix to it called as Jaccard similarity, standing for JS. What this says is very important. This says, so this is called as Jaccard similarity. Jaccard similarity. Okay, very useful metric or measure in machine learning, used extensively in machine learning. Jaccard similarity between two sets is the size of the intersection by the size of the union. Now look at what happens. Okay, if I use Jaccard similarity between Vi Vj, the union is the union here, the union of Vi Vk. There are 4 elements here, there are 4 elements here. So the union here is 4, cool, and the intersection is also 4. So the Jaccard similarity is 1, right? Now the Jaccard similarity between Vi and Vk, the intersection between Vi Vk, there are 4 videos which are in the intersection. There are total of 7 videos between both of them. 1, 2, 3, 4, 5, 6, 7. There are 7, sorry, not videos, there are 7 users, I'm sorry. Okay, so 7 users have watched both Vi and Vk. So the union consists, this union of Vi Vk consists of 7, right? The intersection consists of 4. There are 4 users who have watched Vi Vk, but there are total of 7 users who have watched either Vi or Vk. Actually, in the comment section, somebody said, can we use or also in addition to and? Actually, one of the students said that, but he didn't go into the depths of it. This is like saying either Vi watched or Vk watched. This is like saying this is like saying count the number of users who have watched both Vi and Vk. This is like saying count the number of users who have watched either Vi or Vk. That's the logical or, right? If you think about it from a computer science perspective or logic. Now what happens if I use Jaccard similarity? It is scoring Vi Vj to be more similar than Vi Vk. And this is what we want it to do. See, we always invent mathematics. We create new mathematics to solve the real world problem. Everything that you have studied in your life, every mathematical concept that you have studied has been created to solve a real world problem, including complex numbers or imaginary numbers. Many people think imaginary numbers are imaginary. No, they have been created for a specific purpose to solve problems in physics, right? So Jaccard similarity is a concept which is created to solve this problem wherein Vi Vj should be more similar and Vi Vk must be more dissimilar, right? They should be more dissimilar. These both must be more similar. To solve that problem, Jaccard similarity has been created, right? So instead of using simple similarity, it is better to use Jaccard similarity to avoid the problem of popular videos, right? So very interesting concept. Again, this is how, whenever you learn a concept in machine learning, data science, anything, learn why we need it. That is super duper important. Okay, if you don't learn the reasoning behind it, you are just remembering things by heart. Now, whenever somebody tells me Jaccard similarity, I don't remember the formula sometimes, to be honest with you. To be really honest with you, sometimes I don't remember the formula by heart. But I remember Jaccard similarity is created. I know that this whole metric is created to solve this type of problem. So I can derive it literally, or I can verify the formula on Wikipedia. I understand why it's needed. Why is very important. Always ask why. Pucho kyun. Okay, in my mother tongue Telugu, adagande enduko. Okay, you have to ask why the heck has this concept come into existence. Okay, pucho kyu if you're a Hindi speaking person. I don't know any other language, sorry. I know Telugu, so I can say enduko adagandi. Okay, super duper important. Okay, sounds good. Okay, sounds good. Okay, let's go down. Now, just like we have computed similarity between videos, I can also compute similarity between users. Same concept. If I think of this user as a set, all the videos that the user has watched as a set, I can think of all the videos that the user J has watched as a set. Now I can compute Jaccard similarity between user I and user J. This is another way of thinking about it. Just like the way we have computed similarity between movies, I can think of similarity between users also. Now how do I use this? If I know that user I and user J are very similar, let's assume user I has watched these 2 movies, he has also watched this, he has watched this, and he has watched this. Let's just say, now user J has watched this, he has watched this, he has not watched this, he has watched this, and he has watched this. Let's just say. Then the Jaccard similarity between user I and user J will be very high. Let's ignore all the other movies. Okay, because there is a lot of intersection in what these people have watched, and their union is also pretty healthy. Now, because user J and user I and J are very similar, is there a movie that user I watched that user J did not watch? Yes, there is this movie or video too, which user, we know that user I is very similar. We know user I is similar to user J. We know that. Okay, based on a metric like Jacquard similarity. Now I can say, okay, user I has watched 1, but he has not watched, but user J has not watched. So for user J, I can recommend video 2. Okay, because they both are very similar users. For example, imagine this is a tech guy, okay, who likes tech reviews. This is also a tech guy, okay, who is or gadget guys. Okay, let's just call them gadget guys who love cutting edge gadgets. Okay, I'm one such guy, especially with computational tools, etc. Right? So I love the most advanced laptops. I enjoy them. Okay, I try to get them whenever I can afford it. Okay, so let's assume these two are very similar. So if there's a new review that was launched by a reviewer about, let's say there is a Surface Pro 7 that got launched, or Surface Pro X that got launched very recently, I think just 3-4 days back. So this user has watched it, and he probably watched the whole video to the end, and this user hasn't watched it. Probably he didn't have time at office or at school or at college, right? So it makes sense to suggest this video to this person, right? So you can also use similarity between users as a very nice way to think about this, right? So now let's go down. Okay, now the biggest question is, how do you deploy this? Again, I'll not be able to go too deep because we are already have already just finished 1 hour into the discussion. I'll spend 10-15 minutes just going into this. Okay. So again, how do you deploy this? You have typically like 1 billion plus users, hundreds of millions videos. New videos are watched regularly. How do you do it? Remember, you have this matrix S. This matrix S is maybe 100 million. So we write MM to represent a million. Right, 100 million is 100 into 10 power 6. Okay, that's the number of rows that we have. Okay, this is the similarity matrix, right? And the Sij value, this whole matrix, similarity matrix, similarity between. So this is my similarity matrix, which is M cross M. We have talked about the. This is basically my. This is called as my video similarity. Let's just call it video similarity. In Netflix recommendation, it's called movie similarity. Right? So when I have this similarity, this matrix, each cell here is a floating point value. If I use Jacquard similarity, this is a floating point value, and floating point values can take like 4 bytes or 8 bytes depending on the programming language you're writing it in, right? And how many cells do I have? I have 100 into 10 power 6 into 100 into 10 power 6. That is 10 power 8 into 10 power 8. So I have 10 power 16 floating point numbers that I have to store. Wow, this is like crazy. This is literally like crazy thing, right? So how do we now do hacks? Again, engineering is all about working around real world constraint like this, right? So instead of storing, look at the hack that many people do here is for this movie, let's say this is, or for this video I, instead of storing similarity with all other videos, I could just say I don't care about all of them. For every video, I will just store the top 10 videos that are similar to this. So this video is, let's say, similar to V1. It is, let's say, similar to V3. It is, let's say, similar to V6, so on and so forth, V196. For each of these, I'll store a number. Let's say this number is 2.6. Okay, some number here. This number measures similarity. So technically we should, so let's assume this number measures similarity. Like, let's assume this is 0.8, this is 0.6, this is 0.1, this is 0.06, something like that. So instead of storing this big matrix with 10 power 16 floats, okay, I mean, that's like crazy. What is 10 power? Let's understand this, right? What is this? This is 4,000, 4 into 10 power 3 into 10 power 12. 10 power 12 bytes is a terabyte. Okay, you need 4,000 terabytes or 4,000 terabytes of RAM to store this in main memory. I don't know of any system which has 4,000 terabytes of main memory or RAM. Right? We don't have that. So instead of that, what engineers do is they simplify the problem. They say, instead of storing all this information, all I need here is for every video, I just store information about the top 10 videos in some data structure like a hash table or a database table, whatever it is, simple stuff. This will simplify the problem. So once you have this, how do you productionize this? Look at this. For productionization, you have to first reduce the data size. I can reduce the data size here. Right? Suppose if I have 100 million, 10 power 8 movies, Okay, now I have to store 10 numbers corresponding to it. Okay, so 40 bytes, right? So what is this? This is 4 into 10 power 9 bytes. What is 10 power 9? This is 4 GB RAM. This is approximately 4 GB RAM. Many of you have 4 GB RAM. So instead of requiring 4000 terabytes of RAM, now we are solving the problem by just using 4 GB of RAM. That's it. You can actually you can launch a system to solve this on your laptop now. Okay, these are engineering hacks. These are engineering hacks that engineers build up. This is one way. Again, if you have this data, if you have for every video the top 10 videos that are similar to this, it's very simple. If a user is watching video VI, you can just go to this big data that you have stored. You can store this in a database table also if you want. What is this? It's simply a database table, right? Each row will correspond to a video. Each column will correspond to the top 10 videos and their corresponding scores. That's it. You can put this in a standard database, like MySQL or Oracle and solve the problem. So these are again, when you're productionizing it, when you're deploying, there is a concept called APIs. So we have done some live sessions on how to productionize and deploy machine learning models. We have done like a 2 hour we have done 2 live sessions, 2-hour live sessions. So those who are interested can look up those things for more details. But I just wanted to give you a hack on how actually things like this are implemented in practice, right? Now one more concept before we leave is, now how does this thing get connected to your 11th and 12th class mathematics? Again, since we are short of time, I just give you a very high level overview. What we have here is a matrix A. Look at this. This is my data matrix. My A is my data matrix, right? Now my similarity matrix can also be written as, look at this, I can just multiply A transpose with A. We all remember A transpose, right? What is A transpose? If you remember your 9th class, 10th class, 11th class mathematics, what is A transpose? Change your rows into columns, make your columns into rows. So A transpose, every row will correspond to a video, every column will correspond to a user. So A transpose A, matrix multiplication, A transpose A, matrix multiplication from your high school days, probably from your 10th or 11th class days. We were never taught why we need to do this, why transpose is required, unfortunately. Okay, of course, there are some good teachers who might have taught you that, and huge respect for those people, because that's what I would want students to learn, right? Especially when you're younger, if you learn it like that, pucho kyun will hit your head. You'll never forget concepts. Okay, so now look at this. So when I multiply both of them, what I get is actually the similarity matrix. So your S that you have, the similarity matrix that we have been talking about till now, is nothing but A transpose A. If you think about it from matrix algebra, A transpose A is nothing but your similarity matrix. Your similarity matrix, remember, for your similarity matrix, you can compute eigenvalues and eigenvectors. And again, in the interest of time, since again explaining eigenvalues, lot of times we learned eigenvalues and eigenvectors from a theoretical viewpoint. We learned lambda v equals to AV, right? That's a formulation, right? A minus lambda I into V equals to 0, right? So AV equals to lambda V. So we know, again, some of you may remember this formula, but why do we have this? Okay, how is this related? How is this whole eigenvalue, eigenvector related to recommending systems? Right? Again, so it is related. I'll not be able to explain that in like 10 minutes or even 1 hour. It will take me a lot of time to explain the intuition behind why we need eigenvalues, why we need eigenvectors. Actually, we have some free videos for those of our registered students can access all of this content on our course videos. So please go check out Applied AI course. Just log in with your Google or Facebook account. There are a bunch of free videos in the chapter data visualization. There is a chapter called data visualization in which we explain why we need eigenvalues and eigenvectors and what they actually mean. So there is a concept called as principal component analysis where we explain this. This is freely available. It's also available on our YouTube channel. Please go check out these concepts. But broadly speaking, based on the concepts of eigenvalues, eigenvectors, there is a concept called singular value decomposition and matrix factorization. This was one of the state-of-the-art techniques till about 2014. Till about 2013-2014, singular value decomposition and especially matrix factorization based methods, which are based on eigenvalue, eigenvector concepts, were the most popular state-of-the-art methods for recommender systems. Today, in 2019, It is deep learning systems plus reinforcement learning. Of course, there is some matrix factorization also being used, but a combination of all of them is the cutting edge today that I know of, which is used extensively in industry, right? So with that, I'll take leave. Just a second. Okay, just a second, folks. Hey, thank you all for joining in. I'm sorry I ate 8 minutes into your time, but I just wanted to give you a glimpse of, the whole objective here is to give you a glimpse of how simple mathematics can be and how applied things can be. It's important to not just learn the formulae, the concepts, but it's important to connect them, as somebody rightly pointed out in the early part of the discussion. It's also understand why we need a concept. Because if you know why a concept is needed, you will not forget it. Now, you'll never forget Jacquard similarity in your life, because you know why Jacquard similarity was invented in the first place, to solve it. Because whenever you think of recommender systems and you think of popular videos, see, you have to connect the concepts to things that we see every day. We always see popular trending videos, right? So whenever you see a trending video on your YouTube live, and whenever you think of recommender systems, Jacquard similarity should strike your mind. That's how you'll never forget a concept. That's how I remember, to be honest with you. That's how I remember concepts. I don't remember, again, it took me a couple of seconds to write the eigenvalue formulae, right? Because I don't remember formulae. I know how eigenvalues, eigenvectors work in the geometry of things. Because as I told you, I learned from the first principles from geometry, asking, why do I need this concept? For those of you who are learning machine learning, we thought this session will put you on the right track, help you learn machine learning from a first principles ask why concept. Pucho kyu, adagande enduko, ask why. Okay, hope you have great learning ahead of you, and all the very best. Thank you, folks. Thank you for joining on a Sunday morning. Sorry for eating 10 more minutes into your time. Bye-bye. See you.